Well, I think I'm here. Is that working?
Dan, it's Bob Allberger. I can see you.
Can you hear me?
Yes, I can.
Okay. I'm going to try to pay attention to this thing, but I'm also prepping for the eclipse event we have Sunday night, so I'm really covered.
Yeah, I'm doing the same thing.
Okay. All right. So we're all in this.
Same
Okay.
page. Yeah.
And you are?
Pardon me?
Murray? I couldn't hear.
How about now? Any better?
Yeah, that's better.
Okay.
Okay.
Maybe I should get the headphones and my microphone out. I haven't used that for years.
Yeah.
Okay. Can you hear me?
Yeah. Mhm.
Oh, good.
Test.
Howdy.
Hey.
I was saying that I'll probably barely be able to pay attention. I've got 23 things going, as I'm sure you do.
Yeah, I got your email there. Yeah, we have a busy Sunday night, don't we?
Yeah, and then next weekend is Astronomy Days at the museum. So
Oh, okay.
we're dealing with that too.
How many are you expecting on Sunday?
That's the key question, and who's paying for it. We're spending all morning deciding this.
Yeah.
Negotiating with Rachel. If you've ever communicated with Rachel, well, I need to say no more.
Okay. I haven't. But, yeah, the Moorhead Planetarium has taken the lead for us, and their Facebook site says 7,000 people are interested.
Yeah.
I doubt 7,000 will show up. We had 3,000 or 4,000 for the Venus transit.
Wow.
They all came up to my space, which probably holds 100.
Yeah.
We violated every fire code on Earth, I'm sure.
Yeah.
I think there's
we're holding a ticketed event at DSO and holding it down to about 50 or 60 because it's just hard to manage the parking and everything.
Yeah, that's.
Plus, we're supposed to have a dose of snow, and it's going to go down to 8 degrees that night. And normally, after an involuntary experiment, we've determined we have to close the dome at 15 degrees, or you won't be able to close it.
Oh, okay.
So my plan is to open it before it drops to 15 Sunday, and then I'll stay there all night. And when it warms up Monday, I'll close it. I can't have a nice event going on and I can't open the dome. That's not.
Yeah. It's not supposed to rain, so it should be okay.
Right.
Yeah.
So.
But that is a little risky, having a dome stuck in the open position.
Yeah, we determined that a few years ago. We had an observing run going in situ classical mode, and it got down to 13, and the filter wheel quit, and so we went to close the dome, and the dome would not close. And so we just had to go to sleep at the Lowe's house and wake up the next day, and we'll open it, close it when it warmed up to a balmy 17 or 18.
Yeah, it will get cold. I'm actually.
I think it'll be cold down your way too.
Yeah, it's gonna get. I think it saw something like 18, and I'm hoping it keeps some people away.
Okay.
Anyway, it's not my show. The planetarium's doing it. They just. I said, sure, I'll help. And it's gonna look better through tiny telescopes anyway. I don't know why people want to come up and look at it through the big scope, but
yeah,
whatever.
Yep.
So, thanks all for joining. There are a total of 14 people who expressed interest. Most can attend at this time, but not everyone. So some people may come and go. We may have different people different weeks. Let's just start by going around the squares here, and we can all introduce ourselves to each other. I'll start. I think you all know me. I'm Dan Reichert. I'm at UNC Chapel Hill, director of Skynet, and have been developing these labs for about 10 years, and hopefully we'll get this NSF funding and we can build on these and make a whole nother course sequence as well. That should be pretty cool. I don't know if we're all in the same order here. Robert?
Yeah, Bob Allberger from Towson University. And I've been using Skynet for 3 years at the university. This will be the third semester. But I use Skynet Junior for the last 4 years, off and on, different organizations.
So you were with Skynet Junior Scholars?
Yes.
Okay, I didn't know that.
Okay, so that's how I got started here with the university.
And I don't think we've ever talked face-to-face. How's it been going for you, the lab sequence?
We're having a trial and error trying to combine it with our existing course. But we're working it out. Each semester it gets better and better.
Yeah, that's going to be a challenge because everyone does Astro differently. Some people do it all in one semester. Some split it between semesters. Some have the lab integrated. Some have it separate. So everyone has to take a slightly different tack to the material.
Right. That's what I think. Next.
Let's see. Dan?
Okay, do I have to do something to make myself visible, or how does that
Nope,
work?
you're visible. I see you. Does everyone else see you?
I see you. I mean, but in the main window. Anyway, I'm Dan Caton. I'm the observatory director at the Dark Sky Observatory at Appalachian State University. And I've been involved with Skynet. We've used it in classrooms just informally, not with any written up lab procedures. And we've had 2 scopes on Skynet for a long time. I think our 14-inch was one of the very first non-prompt telescopes on Skynet. So we've been leading the edge on that and have enjoyed it, although it's a lot of work, and telescopes have problems and you get emails in the middle of the night and you deal with it, but it's been good.
You all produced a nice how-to paper. I think it was published in PSP, right?
Right. It's how to put a telescope on Skynet from the client viewpoint, and
it was a master's thesis.
Yes, it's based on Adam Smith's master's thesis. He's a student who's now a science system associate, or whatever they call it, a systems guy at Gemini North.
I saw him. I was giving a talk at Asheville Astronomy Club, and he asked a question at the end. I said, "Oh, a real astronomer," which of course upset everybody in the room. I didn't think about that. Alice.
Hi, I'm Alice Pevyhouse. I teach over at City College in San Francisco. And I have not used Skynet before, so I'm really interested in kind of seeing how this all kind of integrates into my course curriculum.
Tad.
Hi, Tad Thurston, Oklahoma City Community College. I was introduced to Skynet and met Dan at a conference this summer, so I'm still kind of a babe in the woods, but hoping to really use it for my students. I think it ties exactly into what I'm trying to communicate with them about how accessible the universe is to them, and kind of demystify what it is that scientists do. So yeah, happy to join and learn, and say what's up to Jackie. Jackie, is that you?
Yes. Hey, Tad.
What's up? I haven't seen Jackie and I went to grad school together. I haven't seen her in years. That's quite a surprise.
Sorry.
Yep, carry on.
Well, you're next, Jackie.
Oh, can you hear me?
Oh yeah, very well.
Oh, okay. All right. I'm Jackie Malingo, Gettysburg College. Dan, we met a long time ago, but I'm a newbie to Skynet. Yeah, we're kind of struggling a little bit in our labs in the wake of Clea and Larry's retirement, and sort of what to do with our outdoor labs in particular. So yeah, I'm
And
Ryan
Clea's
Johnson.
been great.
Pardon me?
Clea's been great. Yeah, I met you, but I visited. My parents live in Gettysburg, and so it gave me an excuse to visit the college and visit with Larry. And he sat on a number of our advisory boards. I don't want to put words into his mouth, but he often views Skynet as kind of a next step beyond Clio.
Yeah.
From simulation to real scope.
Ryan Johnson couldn't be here today. He had planned on it, but it's snowing here, and he's got it. So.
It means it's snowing on my parents, and so I should check in on them. But
yeah, it's not that bad.
Okay.
But anyway, we're looking forward to learning a lot and seeing how we can incorporate these labs into not only our intro courses, but we were also interested in using them for advanced lab type courses.
See, everyone does different things with them. And, I'll mention the status of the proposals in a little bit. But if this NSF one gets funded, we'll be building a second level curriculum. Though some people may choose to use this current curriculum, the OPIS, our Place in Space curriculum, for multiple levels, higher level. Anyway, we'll go through some of that stuff that may be coming up soon. And how do I pronounce your first name?
Me, Kalee.
Kalee. Kalee. I always do it. I've been trying to get it right in my mind. Kalee. Okay.
I'm Kalee Tock. I teach at Stanford Online High School, which is a high school with pretty advanced students that kind of are all ages, so like all maturity levels, yet pretty scientifically advanced. I'm really excited. I guess I missed Dan Caton's introduction, but I'm excited to see him because I think I read one of your papers as part of one of the projects last year that we did in my astronomy research seminar. And I'm really looking forward to using Skynet in it. We actually have used Skynet before, but for simple things like making color images through Skynet Junior Scholars. So I'm really excited to take it to the next level.
And what was the application that you used to combine the colors?
We used the one that was on the Skynet Junior Scholar site. So I think that was Afterglow, but it was an earlier version of it.
And maybe I'm not fully familiar with all the SGS curricula. That's, I'm just doing the technology piece. But the current version of Afterglow does not do color. So
okay, it might have been Astro Image Processor.
Okay. Astro Image J.
Whichever one they told us to use on the Skynet Junior Scholars site.
And as you'll see as we go through these this semester, our Afterglow program, and many of you know this, and many of you have been using it. It's been around for a decade. It's Flash-based, so that's no good. And with Tim Spuck, there's a $2.5 million grant which we get about 300, 400,000, and we've been building a new Afterglow. It's truly impressive. The existing Afterglow was built just to do what was needed for the OPIS curriculum. This new one's going to be general purpose. It will very easily do color and stacking and things like that. And I keep saying it's going to be ready next semester, and I keep pushing it off, but it's getting really close. And actually this semester, as I'm showing you how to do things with the old Afterglow, I'll also show you the state of that task in the new Afterglow. And I'm hoping by fall to really retire the old Afterglow. I'm going to spend summer doing a lot of updates to the labs that we're going to be looking at. As we go through, I'll say, well, we've changed this and we've changed that, but it hasn't been changed in the text yet. Okay, and other people may pop in and disappear. This was the best time slot, doesn't satisfy everyone. We have one person on the other side of the world who's going to be watching these by video. I am recording these sessions, I think, and I normally use Google Hangout, but it only supports up to 10 people, and we had 14, 15 people on the list. So I just subscribed to Zoom, which I've used with other people before, but I'm still trying to figure it out myself. But so far, so good. If we have any technical problems, I'll know, but it's recording it, and anything we put in the chat window is recorded as well. And after some processing time, like 30 minutes, you'll all have access to these discussions to refer back to. Okay, let's see on my list here. I'll give you an update on the grant situation because I think you were all involved in the grant spree we went on last semester. Crazy busy semester. It began with the conference in the back-to-back conferences in Hawaii. Well, we got one more right now, so let's do one more introduction before going on. Jacob Brown, can you hear us? Okay, so give us a little introduction.
Hi, I'm Jacob Brown. I am an instructor over at North Carolina School of Science and Math. This is my second year here. My background is in astronomy, so I'm teaching astronomy here in March. So.
Okay, great. Now, you missed everyone else's introduction, but you'll catch on in time, I'm sure. And plus, as I was just saying, these are being recorded, so you can go back and watch the bit that you missed at the beginning. Okay, first, just a quick grants update. I teamed up with Michael Fitzgerald, who, of course, runs the RTSRE conference. He's been a great partner, and his whole team has come on board. They've been great to work with. I'm always a little cautious because we have an education research group here at my home university that is just absolutely horrible, I'll just say it. And so I've always been scared and nervous about working with education researchers, but working with Michael has been a great opportunity. Anyway, we teamed up. We put out two proposals. One was a $1 million pre-proposal, trying to get the permission to write a full proposal to the Spencer Foundation, private foundation. And the other was a $2 million proposal to NSF through their IUSE program. We heard back from the Spencer that we did not get the invitation to do the full proposal, and not sure what to say. These private foundations, it's hard to know what they're looking for ahead of the time. It's a little opaque, and they do not give feedback at the pre-proposal level. So, I don't know, it didn't work. But the NSF IUSE proposal is still out there. We submitted that in early December. These things take about 5 or 6 months at best before we hear back. And I'm optimistic. I've had success with NSF education and also NSF science. My track record is about 50%, which is pretty good. And normally it's 15% to get grants. And I feel like I built an all-star team. And then with all of you and so many other, we had probably 60 letters of support. If we don't get it, I'm hopeful it'll be favorable reviews with a few things to fix, and we'll send it in again. This doesn't mean you have to wait until the money comes through. Whenever it does come through, even if you've already been trained, like this semester, you can still participate in the program. And that one will be more general. That grant covers two things, doing some updates to OPIS and doing a study of some of the interesting effects that the OPIS curriculum appears to be having on student enthusiasm and retention. And OPIS, Our Place in Space, is really meant for a broad audience. And then the second part of that grant will be developing the multi-wavelength universe curriculum. just to break down the two curricula for you real quickly. OPIS, which is what we've been running for 10 years, it just needs a few updates in a few places and adaptation to the new afterglow analysis tool that we're building. This is meant to scale. Sorry, I'm on a video con. I'll call you back. Thank you very much. Bye. There are only two calls I always pick up. One's my wife and one is my administrative assistant. And they're the two who actually know what's going on and tell me what to do in life. So that was my admin, so I had to pick that up. So OPIS is meant to scale. And so we designed it to be maximum bang for the buck. We don't try to do color images in OPIS because that's 3 or 4 times the observing time. A lot of it's solar system targets, which are really short exposures. It's built around the cosmic distance ladder, which is an organizing theme for many introductory astronomy courses. And it's designed to scale to tens of thousands. Currently, 1,000 students do it per semester, but there's no reason we couldn't support 20, 30, 40,000 students. Part of that is how we've re-engineered Skynet. One thing we've added is if there are multiple observations at the top of the queue that are identical, we observe it once instead of n times. And since these students are all doing the same lab, we give them the same objects or short lists of the same objects to look at to encourage that redundancy. And that's what will make it scale to large scale. So hopefully this is a robotic telescope curriculum that can go national or international. It's currently in about a dozen institutions and about 3 or 4 dozen signed up for the grant. So we'll take one leap and we'll see where it goes from there. The exciting thing about OPIS that has generated the NSF money in the past and hopefully moving forward is when we implemented it here at UNC, enrollments more than doubled in our introductory astronomy courses. There's something special. You could just tell it from the students. They're excited to be using these telescopes. Maybe it's because they are, quote, real telescopes at, quote, real observatories being used by, quote, real scientists to do, quote, real science. The realness aspect. I'm just hypothesizing. Part of what we would study in this grant is figuring out what's causing this. But that may be causing the enthusiasm or the attitude game. Another aspect that we think is the ownership. Like, I did this, this is my own. And we did do early there was an early study across about 10 institutions, and we did not see these kinds of results in labs, traditional labs that use small telescopes at night. So there's something special about this. And it also led to about a 300% increase in AstroTrack majors. Now, we don't think that's exclusively due to this lab. What we think happened is this lab got students to come back and take another course. And in our second level course, as many as we can take, which is only a fraction of the course, it's usually the upper fraction. The following summer, we take them to Green Bank Observatory and do an intense, awesome experience on radio observatory, radio astronomy, and multi-wavelength astronomy. So this second curriculum that we built into the proposal, the multi-wavelength universe curriculum, is trying to capture some of those experiences, but bring them back into that second level classroom so everyone can experience it and see if we can get the same lightning in a bottle effect and increase AstroTrack majors. We went up 300% there from 5 per year to 20 per year. And it led to us hiring more astronomy faculty and all sorts of good things. That's kind of the gist of the proposal. And that second curriculum, being for a smaller number of students, we'll be able to give them more time. They'll be able to do color imagery. It's built not around the cosmic distance ladder, but will be built around emission mechanisms, which are a popular thread through second level astronomy stars and galaxies courses. Anyway, we're not going to talk about that curriculum yet, just saying that the color stuff, and there'll be a big radio emphasis since we have a 20-meter diameter radio telescope on Skynet. That will all be built into multi-wavelength universe if and when we get the money, and all the participating instructors will help build that curriculum. Okay, so what we're going to do this semester is we're going to run through OPIS 1 week at a time, 1 lab at a time, and that's okay. And you could do that, and there's a mute button in the lower left if you need to. Yeah. And And also somewhere there's controls where I can mute you if I want to. I still haven't figured that out. But okay. And let's see here. Okay, so the Art, Place, and Space curriculum, it is 8 labs at UNC. 2 of them take 2 weeks. And the first one, well, let me share my screen. I'll just start showing things. Let's see, screen share. And main screen. And I think that is... Let me move something over there. Okay, I'll move your photos over there. Okay, so this is just a little tangent, but it'll be useful a little bit. So all these labs, we also make them available to the public because some people are just interested in doing them without having to pay tuition. So this is a website where the labs and some other things are available. And I'll put these things in the chat window if I can figure out how to do it while sharing. Or I can't figure that out right now, but I will send these links around later. But in this screen here, you can see kind of an overview of the Art, Place, and Space curriculum. Just a few points describing each lab. I'll run through it really quick. The first lab is just learning how to use Skynet, learning how to use Afterglow. We do Skynet the first week, Afterglow the second week. And it's an exploration of the solar system, essentially. And so not really heavy on the science, but it's learning the toolkit. And once they learn these tools, they'll be able to use them throughout the rest of the lab. Often, at the end of each lab, they put in their observations for the next week, because the observations don't always come back in real time. So 1 week is usually a big enough buffer. End of lab 1, they put in the observations for lab 3, and then we do one of the non-Skynet based labs. When we sat down, we said, what do we want them to learn? Not what toys did we have. We have this great planetarium. We had small telescopes. We'd take the students out at night to look at the cloudy sky and the rain and the snow, and then give them a terrible set of backup labs, such as here's a photocopy of a fax of a scan of the moon, measure a crater. And it was horrible stuff. They didn't like being there at night. We've been able to switch all of our labs to daytime labs because of Skynet. I think that also helped boost the enrollment. Anyway, it's driven by what we want them to learn. Lab 2 is, why is it hotter in summer, colder in winter? Common misconception. We actually have 2 versions of this lab, one using globes and lights that I really like, but also one that's completely stellarium-based for the online students in particular. Lab 3 gets back to Skynet. This is the Galilean revolution. And so they're going to be measuring phases of Venus, seeing whether we live in a geocentric or heliocentric universe. And also they're going to measure the orbit of a moon going around a gas giant of their choice, and use that to measure the mass of the moon using Newton's form of Kepler's third. And I should say, if some of this stuff sounds a little advanced for an introductory course, and you'll see there's some pretty advanced stuff as we go on here. Some of this stuff was more advanced than they were doing in our advanced observational undergraduate course here at UNC. But we built the tools to make it easy. Often, we had to make a philosophical choice. Do we want the students to come out and fight with telescopes? Because that's what it is. In the small telescopes, they go out, they're fighting to make them work. Mostly they're learning how to use a telescope and not learning the science. And learning how to use a telescope, I think, is a very important thing. That we decided that's something more for the majors. For the introductory students, where this is the last course they're ever going to take, and for many of them, last science course they're ever going to take, we want to skip over the technical challenges and get right to the science. And that's what Skynet provides. It's a fairly reliable system where they put the observations in, they get the data back, and we focused our resources on building analysis tools so they can extract science from their images. It's not just taking pretty pictures either. They will be measuring stuff and coming up with conclusions. Also in lab 2, they measured the size of the Earth, which is the base of the cosmic distance ladder. And then we get into our parallax lab in lab 4. There is a manual parallax exercise, but they measure parallax to a main belt asteroid and parallax to Venus to define the AU, and then parallax to Alpha Centauri using the AU. In lab 5, we continue on the cosmic distance ladder. using apoligize and Cepheids. Apoligize, they figure out how to measure distances within the galaxy, typically the globular clusters. Cepheids, they can get to nearby galaxies, and then type 1a to get to far away galaxies. Lab 6 is a little tangent from that. We're going to put these skills into use, and we're going to repeat the Great Debate from 1920 using the apoligize to figure out the scale of the Milky Way and our place in it, and using the Cepheids to determine if the spiral nebulae are galaxies like our own or little things that orbit the Milky Way, which was the nature of the debate. And so they're doing these things, and in most of these labs, they're taking at least some data themselves. Lab 7 is a tangent. It's a lab that we designed to fill a number of boxes. In Lab 8, they're going to do Hubble's law and learn cosmological redshift. So we felt they had to learn Doppler redshift first because they're different. And we also wanted them to have some spectroscopy experience. So this is an introduction to our radio telescope where the students will be taking spectra from it. Right now they're using archival. They can acquire the spectra through Skynet, but we haven't built the analysis tool to go along with it. But we will. And they measure the rotation curve of the Milky Way and the mass of the Milky Way. So it's also a tease into dark matter. That's the carrot for that lab. And Lab 8 is not Skynet based. It's on Hubble's law. It's I love this lab. We spend a lot of time designing it. It uses rubber bands, but they measure Hubble's law from these one-dimensional universes. They show that it doesn't matter where you're standing. Everyone sees the same expansion. And we do accelerating and decelerating universes as well, compared to the type 1a supernova data, and they learned that we live in an accelerating universe, so it's a carrot to dark energy. And if another separate proposal that I put in is funded, the broader impacts piece, we're going to add a new lab on the multi-messenger era. Skynet was the second of 6 groups to discover the optical counterpart of the gravitational wave detection of emerging neutron stars. And so we're beginning to design a lab around that, in which you'd use not standard candles, but standard sirens to measure Hubble's constant spectrum. Anyway, that's the broad overview. Not everyone does all the labs. You don't have to do all the labs. It's pick and choose. It's whatever works best for you. It's very flexible. Okay, any questions about the grand overview? If not, I'll jump into Lab 1.
I have one question. I was just clicking around these labs as you were speaking about them, and for one of them, I looked at the sample lab just from the Skynet website and clicked to Afterglow for I guess it was the distance ladder one, but it's probably the same link from all of them. And it was asking me for a username and password.
That's right.
So is it possible for students who are not enrolled via Cengage to create one on Afterglow, or do you need to?
Yeah, Afterglow is separate from Cengage. It's tied to Skynet. So their Skynet username and Afterglow will get them in.
Gotcha, thanks.
And the new Afterglow will be fully integrated into Skynet. It won't feel like a separate thing. It'll feel like part of the same tool. So it will be a common login through that framework.
Cool.
Okay, so for Lab 1, actually we bring the students in a week early just to do some basic orientation stuff to get them set up on 3 primary software packages. So let me go through those first. Let's do Skynet first. Now, many of you have Skynet accounts. Those of you who didn't, I sent you an email this morning, and so you can find that and follow the directions, and you'll be able to complete your Skynet account. And it used to be you had to enter them all, every student in your class manually. It was a real pain. Now you'll see there's a simple way to just type in a list of emails or a list of email addresses, and then these emails go out and they can complete their own registration. So let me pull up, let me bring Skynet over. So do you all see the Skynet website now? Is that how this is working? Okay. And let me just go back to the home page. So once you have your Skynet account set up, I've created a group just for us. Gave you all half an hour of optical time, which is what the students get, half an hour of radio time, which right now the students don't get any, but they will get some, just enough to do Lab 7 once we connect that to our radio telescope instead of the archival one. A lot of this was built up with archival data, and slowly we've been transitioning it to the real telescopes as we build more and more infrastructure. Okay, homepage doesn't have much on it. I'll just give you a quick tour. My observatory, you all should see optical observing, radio observing, my account, which is like changing password and name and stuff like that. You can explore that on your own. And once you have a class doing it, I will create a group and make you the group manager. So you'll see that group management tab as well. You can see there are other tabs for higher level administrators that I have, but you won't need to worry about. I'll come back to that stuff. I'm going to show you group management in particular today, and before we get into Lab 1. So you see, because we put a lot of effort into making it easy to create groups and add students, and I'll show you a few tricks there. Skynet Live just shows you what telescopes are currently connected. And we have bad weather in lots of places. We have good weather. Well, we have 2 telescopes on the other side of the world connected right now. They both have good weather. Maybe we'll put an observation on one of those today. Skynet Sites gives you information about all the different observatories. I'll click on Search Lolo because that's where we have most of our prompt telescopes. The prompt has now expanded to soon 5 different dark sites, 2 in Australia, 2 in Canada. Though one in Australia was electrically destroyed, we have to rebuild it, and one in Canada is just in the works. The other one just came online. Anyway, for each one, you get like a webcam and recent images, and you can go to any individual telescope, and it gives you a webcam and what filters are on that telescope, some basic information about pixels and field of view, and a list of recent images as well. And then there's a help. This is for donating money. I don't think anyone ever has, at least not through this web interface, but if you want to be the first, and contact us, really you're better off emailing me. My staff is kind of slow to respond to these requests. If you're using it for research, there's an authorship policy. If you're using someone's telescope, you kind of need to include them on your paper. Anyway, going back here, I'll show you how to do the observing in just a little bit. The optical observing anyway, but let's go to group management. I want to show you how easy it is to manage this kind of stuff. So right now I have our group, intro astro _ S19. I created it this morning. From a higher level up, I can create a group and give it some time. I gave it 2 time accounts, some time on this list of telescopes and time on our radio telescope. Now, there are many more telescopes than just this list. These are the telescopes with small fields of view. Our decade-old afterglow software cannot read in an image that's too big. So as our telescopes have advanced and we've added larger format cameras, that's reduced the number of telescopes available to the lab. And there's still some good telescopes in here, but once Afterglow 2 is ready, you'll have access to the full list of telescopes. And these are only growing. They're currently about 20, and I expect there'll be about 30 in a few years. So that's nice. And the prompt telescopes are UNC telescopes at dark sites, so they're kind of guaranteed to be good. Then we have our partner telescopes, like Dan Caton's telescopes. And his telescopes are good, but some of our partner telescopes are not good. And one of the things about Skynet is anyone with a kind of a fixed telescope, big, 14 inches or bigger, could put their telescope on. We work with a wide variety of different types of small telescope hardware. We figured out all the bugs of all the different standard types, and Skynet's built to autocorrect for about 300 different failure modes. That's the challenge of building a global network. There are so many failure modes that can shut you down. And over the years, I cataloged about 300 that we can autocorrect. Skynet just fixes it itself. Each different hardware has different failure modes and some software components as well. Of course, there are some failure things that it can't fix, and it rings our phone, and then we try to get on and fix it quickly, though sometimes the site goes down for months on end. So you shouldn't get wedded to a single telescope. You should get accustomed to putting observations in on as many telescopes as possible. Anyway, there are different things here. I'll show you create user accounts. See here it's Skynet messages. I have 8 messages that I haven't answered. That's why you should not use this contact us over here, because it gets ignored. But under create users, you can create them individually. by creating a username and a password and some other information. If they're younger than 16, you should put in a birth date, because legally we're not allowed to put their name on the site, and so that trips certain flags that keeps us legal. But most college students are older than that. But if you're doing high school students, if they're under 16, it would be good to have a birth date there, so we don't violate any laws. So that's one way you can create accounts individually, or as I did this morning with you all, you just put a list of emails here. Click this box, send invitation email to new user. You can even give them an initial credit allotment so you don't have to assign it separately. Like I gave you each 1,800 credits, which corresponds to 1,800 seconds on one of our good 16-inch telescopes in Chile. It corresponds to more time on lesser telescopes and less time on better telescopes, as I'll show you. But you can do that and create, and it will send out these registration keys. If they already have an account, they won't get an email. So some of you did not get an email this morning, but some of you did. And those of you can create your accounts, and start using the system. If it ended up in a spam folder and you lost it already, just let me know and I'll do it again. Once you create users, you can manage members. Here's your list, and you can click on anyone you want and give them special access. When I create these groups for you, I will make you the administrator of the group. There's some other things like you can remove users and whatnot. Here's the big one, manage credits. When I create your group, I'll give you some time accounts with some credits. You can click on whoever you like. So Bob here, I clicked on him and I'm going to give him an extra credit of observing time. So that was valued at about 1 penny. But now I've decided I don't like Bob, so I'm going to take it away. And so, it's that easy, and you can click on multiple users and do this simultaneously. If you run out of credits, just send me an email and I'll make sure you have more credits. Okay, we haven't gotten into the lab yet, but that's just basic account management, user management. Any questions about that? It works quite nicely, I find. Setting up the groups and making someone a leader is a little bit more cumbersome, but that's on me. Okay.
Dan?
Yes.
I had a quick question about the birthday thing.
Yeah.
So will the automatic list allow the students to put in their birthdays, or should I just do this by hand for each student?
Yeah, that's a great question, and I can ask my programmers to add that under the auto creation. Until then, you'll probably have to go back through and adapt that. We can still create all their accounts automatically, but you may have to go back in and modify them individually, or you may need to create them individually.
Okay. And is there a way to tell when students if I do the auto create, is there a way to tell when students have registered everything properly, or? With
the auto create, they are registered. They don't have to go back in and register. Their account exists. Now you're typing in a password for them. You'll have to tell them what it is. Usually I just take their username and add 1, 2, 3, and they can go in to my account and change their password.
Okay.
You also have the ability to go in and change people's passwords under, I think, management. It's somewhere in here. And also, if they forgot their password on the login page, it has all the standard reminders, like I forgot my password, please email it to me. And some people won't receive a request because they may have an account from a prior semester. They just have to go to the login page and mess with it until they get their password and username back. Okay, let me check my notes here. I think next I'm going to show you WebAssign, and we'll take a look at Lab 1, but I'll also show you how you can get accounts on WebAssign if you don't have them already, and how your students will. Let me go to the main page. So WebAssign is a private corporation, and we partnered with them to make the labs. I think they did a great job. They're interactive. They do a lot of the grading for you. One of these weeks, we'll spend some time on how grading is done. We won't mess with that today. They do charge $65 for the labs. It's cheaper for high school students. Often with high school students, the high schoolers often will purchase just a couple copies of the lab and share. But in college, it's essentially the same as a textbook. They can either buy it directly from the website, or you can get your bookstore to order cards with access codes already built into them. And the bookstores will mark them up, but those students are paying with financial aid money. And so often they'll prefer to pay with a little bit more with the funny money. If they're paying with their own money, I tell them to buy it on the website. In my own class, I compensate by letting them buy an older edition of the textbook. All introductory astronomy textbooks, they come out every 3 years, but there's nothing really new in them. And by going one edition back, instead of it being $180, it could be $20. Skynet gets a little bit out of this, just to be completely open. Currently, $5 of each one goes to Skynet. It helps me pay my bills. It costs about $350,000 to keep the system working. If we get the grant, they've promised to up it to 10. And that'll be enough money to purchase a dedicated telescope for this. But you don't have to worry, even without a dedicated telescope. I save 10% of every telescope on the system for this and some other things. So it is what it is, but they did a great job with it. So instructor sign up is here. If you don't have a WebAssign account, you go here, fill in your information. They probably won't get back to you for a couple of days, but when they do, send me your username and send me your institution username. It's not, don't send me the name of your institution. They come up with a small code version of it. Send me those two things and I'll add you to one of my existing sections so you can see the labs in WebAssign instead of on that demo page I just showed you. There are a few of the labs there, but they don't really work because they don't submit and interact with WebAssign. You can follow along until then, but try to get signed up right away and I'll connect you and then you can start playing with the labs through WebAssign. Now users, like students, what they will have is in the syllabus, there's a class key. Each section I create for you will have its own class key. I'll just type in one for one of my sections. I'm teaching the labs online this semester. And I wrote down the class key. And it checks and says, yep, this is the right course. Yes, this is my class. Now note, if I sign it up for you, it will say I'm the instructor. What I do is I often set these up for almost everyone because I'm really efficient at it. I can do them all at once. And I then add you as an instructor. But when they sign up here, it will say Dan Reichert, and hopefully that doesn't create too much confusion. I use your course name and number. And then when they say this is my class, they already have a WebAssign account. They can sign in. They need to create one. They can create it here. And they're given a 2-week grace period before they have to pay. Okay. Now, let's, I'm going to log in here. This is what will look like to an instructor when you log in. You can see how many sections are using the labs right now. Lots of them across many institutions. Let me find one of mine. And there are different things you can do. You can change the due dates. When I set it up for you, it will have the due dates for my university. You can change it to yours. But here at the top, there's an open student view. Let me show you what it looks like to the students. And I got to find that section of mine that we were just in. Okay, so already it has lab 1 ready to go for my students. The other labs appear whenever you want them to. I often use this for posting announcements. Like I'll put their grades here, like a link so they can determine their grades. You know, other announcements. But let's just jump right into lab 1. I know we have about 15 minutes, but that should be enough because we're going to do lab 1 in 2 parts. The first part, let me close this up. I had everything open because I was looking at it before. So you'll see what it looks like when they first come. It has this nice accordion feature that makes it very easy to navigate. Almost there. Okay. Here's week 1 where they're just learning what Skynet is and how to put their observations in. And then down here we have week 2, where they can open all these, and here they're going to learn how to use Afterglow to analyze their observations. Again, lab 1's different than all the others. They're just learning how things work. We'll get into the science after this. So today I'm just going to go through the stuff up here, and there's actually nothing for the students to submit. It's all background and how to put their observation in and getting their observations in. And I try to get them to put the observations in right away, like in class or right after class. Now there's some instructions at the top. Usually there'll be a short video of one of my TAs doing a pre-lab talk of about 20 minutes. Since this is the first lab here at UNC, we have them come over to Moorhead Observatory. We do our pre-lab talk here. That's there. There's a PowerPoint in there. I can give you a copy of it, but it's nothing special. And since we're over here at the observatory, we take them up to see the telescope. We have a remote ops room so they can see the telescopes in Chile. We used to have a prompt telescope here in the lab. So we take them around all these things. So we have a few extra videos here. And going up to the telescope is a nice feature. I know you all can't do it because you don't have a Skynet telescope right there on campus. But what we do is I trick the telescope into thinking it's on the other side of the world, that it's nighttime. And I change the dome to a simulated dome so it doesn't open. It thinks it's open, but it's not. And that lets the students go up and they put observations into Skynet. Right after, we show them how to use Skynet, then they go up. They put observations in, and they just see it move around and take pictures of the inside of the dome. But it's an oh wow experience. You can see the smiles just light up on their face when this giant telescope, to them it's a giant telescope, moves before them, and they did that. And it really establishes this is real. They're not being farmed images from some database somewhere. And what I'm hoping to do, I put in a small grant to do some upgrades to my telescope and to streamline this process such that you all can do it too. You'll be able to use my telescope during the day. We'll put webcams all over the place. And you'll be able to say, okay, this telescope, it's daytime scope, but it thinks it's nighttime. No one's using it because it's daytime. And so we're going to put observations in and get pictures back at the inside of the dome, but they'll at least see how it works. It'll be live webcam. And see, all the other telescopes, it's dark when they're observing. So we have webcams on them, but you can't see anything. So I think this would be a nice addition to the lab. There are other instructions here, basic things. Basically, they're allowed to submit the lab 100 times, and the last one's graded. There's no save. The submit is used as a save, and you're given 100 opportunities here. And other notes. The most notable one here is for Lab 1, not all planets are going to be up any given time of year. There are a lot of planets in this one. And so they shouldn't expect to do everything in this lab. They won't be penalized in their grade if they can't image something that's right next to the sun. So you have to tell them that over and over because they freak out. Okay.
I have a quick question on this. How do you, so you said for Lab 1 not actually submit anything, so how do they say they're done? Like if there's the
they do submit. They do submit. They do submit.
Okay, what do they turn in?
So they submit, and then by the next week when they come back, hopefully all their images are back, and then they're going to use them in Afterglow, and then they will turn them in down here in the second part of the lab.
Oh, I see. So they submit, so it's like a 2-week lab?
Yep. This first one's a 2-week.
I see. Gotcha. So they're gonna, but they're not gonna submit anything until the end of the second week.
No, they'll submit everything at the end of the first week with the goal of getting all their observations back in time for the second week. And then in the second week, they will load their observations into Afterglow, make measurements, manipulate them, and then carry out the exercises. But this first week, there's so much. You got to tell them about Skynet and so much background, getting all their computer services working, that we go through all that, and then they just put their observations in.
No, that sounds great. I understand that, but I'm just wondering, what do they submit into WebAssign at the end of this week? Just like some little, I did it? Oh, you're going to show me.
I will show you, yeah. So there's nothing that they actually type into WebAssign this week. You can check on Skynet, make sure their observations are in. Often my TAs make a little quiz at the beginning of each lab. I let them do it themselves so they gain some experience, like a 5-question thing, just to make sure they they read the lab. You can build them right into WebAssign. And so that's at least something registered in WebAssign. Okay, let's go through these really quickly. A lot of them are background, which I won't labor on too much. And then it's procedure, and I'll go into Skynet and show you how to put a job in. And if you're on Skynet now, you can follow along. But the goals of this lab: learn how to observe with prompt or some of the other telescopes. It says in prompt telescopes in Chile and Australia. I need to expand that to Canada as well. And other telescopes around the world on Skynet. That's the first week. In the second week, they're going to learn how to adjust the brightness and contrast levels of their images, because astronomical images have tremendous dynamic range. You can't see everything at once. How to measure angles in their images, distances between moons and planets, sizes of planets. How to find things, identify things. What moon is that? They use stellarium to help them. Where is the dwarf planet in this image? They use the digitized sky survey, which is built into Afterglow to compare and contrast. So where's Waldo kind of exercise. So those are the goals, but 2, 3, and 4 are in the second week. Equipment, for this one, you just need your telescope. Very quickly, just a few of the background sections. We tell them a little bit about the prompt telescopes. Here's our CTIO site, our now destroyed Australia site, that we have another site in Australia, and we're going to be rebuilding this one this year. And fun little links. This is a YouTube video. The dome's automatically opening every night to help with the reality aspect. It's an old video. We have 2 more telescopes there now. This one's a good one. We have a live panable zoomable webcam at the site. And so there are the prompt telescopes. I can zoom out. I can move around just by clicking where I want to go. So you can explore the site. If I keep going and zoom in to one of the distant mountains, you can see the second mountain of the observatory over here with our 4-meter SOAR telescope, 8-meter Gemini, and off to the right they're building LSST, which is great. It means the prompt telescopes will always be there. The observatory will always be there because they decided to build LSST there. So fun little things so they can explore our primary observatories. I will add the Canadian ones to this. Some history: we built prompt to chase gamma ray bursts and had an exciting result about 10 years ago. We've had many other exciting results since then, so we'll probably flesh this out. How a prompt telescope works, just the basics. It may be good to bring even a small telescope to class. The mount is the most important part of the telescope for pointing and tracking. It doesn't, that's the most important part. Second most important is the camera, filter wheel, and the telescope is usually the least important part of the telescope, but it can also be important. Now, most of our telescopes are Cassegrain, and this just shows the basics of how the light bounces off the primary. The secondary goes through a light baffle, to a filter wheel, and a camera. You have to spend some time explaining our cameras are black and white. If you do want to make a color image, you have to take at least 3 images in 3 different filters and combine it after the fact, which the new Afterglow will make possible. So it's not part of the OPIS curriculum because, again, we're on a observing time budget. That said, if they want to have some fun, we encourage them to do so. If they burn through all their time, I'll give you time so you can give them more. The few students that actually burn through all their time, those are the ones who are going to come back and become majors. So we want to encourage them. Now, telescope time is pricey. Everybody else has to buy it through contract, but through this program only, since we built it into our grants, we'll give the time away. And then there's a couple more sections just telling a little bit about the maintenance of the telescopes. These are real-world instruments. They do fail. There are procedures for correcting them. You don't want to get too dependent on a single telescope. And then a list of some of the other telescopes on the network. The list has grown. This needs to be updated. And their general availability. This isn't the quality of the site, but the availability by certain cuts. And I'll check the most recent numbers when I update it. Okay, how to observe with Skynet. And any how-to section, there's always a link to a video tutorial. Here's the link to the Skynet site. Here's a link to a screencast, either by me or by one of my TAs explaining it step by step. Nice thing about that is as we change the websites, we just have to change the videos. Getting WebAssign to change web pages, a longer process, up to a semester. But then I highlight some of the key things. I won't make you watch the video right now, but I will just show you on Skynet how to put an observation in. Add a tab here. I am logged in. So just an optical observation. So it takes you here. Initially, you won't have anything in your list. This is my list of observations. So you add a new observation. That's right here. A couple ways you can do it. You can look it up by keyword, tarantula. It's one of my favorite ones, a circumpolar one in the southern hemisphere. There it is. So always observable. You can also kind of poke around and see whatever is to be seen. There's a cool one in here somewhere. Oh, that's pretty cool. And it's explorable. You can zoom it as much as you want. Planets are here too. You can choose what's displayed. But I've selected, what is this, M65. Okay, yeah, I looked at this earlier today. So a couple ways you can do it. There's also a tab-based version for blind and visually impaired students. This page is compatible with screen readers, but I won't waste any time on that today. You can adapt the username however you want. There are some things we customize. It's not written into the lab yet, but we found it's good. Maximum elevation angle, you can wait until astronomical twilight, the sun 18 degrees below. But we usually tell the students to do it at -12. That's good enough, and the professionals aren't using the scopes yet, so they can get a lot of observations in then. The default comes up as 30. I tell the students to change it to 20. This is how high the observation has to be off the horizon, just a little bit more likely to go through. And minimal time up in the sky. If it's only up for a few minutes, the odds that their observation will go through is so small. But I like a default of half an hour. So I would change the numbers to -12, 20, and 0.5, and that isn't written in the lab yet, but it will be on my next iteration. These are advanced settings like pointing offsets and dithering. We don't need that. And there's an air mass chart, and the video explains how to read it. This is the next 24 hours, one line for each observatory. And this thing that I chose, I should say I had this set for Meckering Observatory right now, but you can see what the sky looks at any observatory at any time. But I know this thing is up in Meckering right now. This is the Meckering curve. So it's up right now. Maybe I'll get it back right now. Otherwise, you have to wait until it comes up. Next, we choose filters. You can choose telescopes first, but normally you choose filters. And you have a whole bunch of options here. The lab tells them what to do. Many, we just pick high through. It's a generic catch-all for any filter that lets a lot of light through. This means you can do a shorter exposure time. And you can see all the telescopes have some version of high through, whether it's clear, open, or luminous. We also have generic red, generic green, generic blue. And as I hit more of these, you see more telescopes get X'd out. They don't have all of those filters. You can pick multiple filters if you want. Right now, I'll just pick one filter. Maybe I'll pick two. I'll pick high through and generic R-band, which is many of the telescopes have that combination, but not all. Let's go with that. And save and continue. Now you pick your telescopes. It's narrowed it to the list of telescopes that have those filters. You can, and these are different time accounts. You probably only see this one right now. If you click the orange button, it will highlight everything that in that time account. I have access to many other telescopes from other time accounts. So if you're running short on time, I tell the students just pick every telescope. You got to get something. But if you have a lot of time, I tell them just go with the prompt telescopes because they're guaranteed to be higher quality. First available will carry out the observation, but select as many as you deem reasonable. Then you go to this page where you're going to design your observation. This is also a little different from what's currently written in the proposal. Skynet's a very heterogeneous system. I know I'm in my final minute. I'll probably go an extra 5 minutes. If you have to leave, I understand. It's a very heterogeneous system. Each telescope is going to have a different response. So you pick a design telescope. And the labs are currently designed around prompt 5. It doesn't say it in the lab, but that's the deal. It will say it in the lab on next iteration. So you'll design your observation for prompt 5, but it will scale automatically to all the other telescopes. So here are the 2 filters I chose. Maybe I changed my mind. I don't want the R band anymore. Or I can add a row and make it R band or another high through. You can design whatever you want. Usually 1 exposure will do it. Maybe I want a 30-second exposure and a 50-second exposure. Now that 50-second exposure, let me just go to one of them to keep it simple. 50-second, 30-second goes back, yeah. So for 30 seconds, it would work on any of the telescopes that were deemed acceptable. As I slide over them, you see on DSO 14, a 30-second exposure on my telescope at Cerro Tololo would take 136 seconds to get the same signal to noise at Dan Caton's telescope, Dark Sky Observatory. Just I'm in the Chilean Andes and he's in North Carolina, not to put down his scopes. Take a little bit longer to achieve the same signal to noise, but it does the calculation for you. And so the students don't have to worry about that or put in different observations for different scopes. Moorhead would take 230 seconds on my crappy telescope above my head. But some of the other prompt telescopes are closer to that 30-second number. Anyway, you'll be charged 30 credits regardless, but you get a larger, you know, on this telescope, it'll go for 250 seconds, but the credits are go farther on this telescope. Anyway, that's the idea. So you can put the observation, it will go on the first telescope available, and it doesn't matter if it's a high throughput giant telescope or a low throughput tiny telescope, you'll get the same signal to noise. You pick whatever time account you want to be charged, save and continue, submit. And then it's in the system. Now I observed M65 earlier this morning, just to remind myself how everything works. It went through our prompt telescope in Meckering, which is in Western Australia. And here's the image. Not bad for 30 or 40. I think that was a 40-second image. No, it turned out to be 52 seconds scaled. You can download the FITS or a JPEG. There's also automatic darks, biases, and flats, masters pre-made for you. Currently, I have it displaying the reduced, but I could have it display the not reduced. So this is the unreduced image. And you can see the stuff in the background, the manufacture pattern, the CCD, some dust. So it will auto-reduce them for the students if they want that, or not if you don't. If you want to do your own reductions, you can download the unreduced and then grab the masters and do it yourself. For most introductory students, just going straight to the reduced is the way to go. Okay, I'm almost done here. That's how you put an observation in. Let me go back to Skynet. No, to WebAssign. Here we are. So they put their observations in, and then they're going to check their observations. They should put them in immediately. They shouldn't wait till last night because they could be clouded out, or there could be equipment failure. They should put them in, and they should check them periodically because there's all sorts of ways an image can fail. It can be cloudy, in which case you see just the dust on the lens or the manufacture pattern of the CCD. Here's partly cloudy. See the dust, the out of focus dust. Here's clear, same object. It can be windy, and so the image may be distorted. There could be a mount problem and it's off center. Tracking may have failed, so everything's blurred. It can be out of focus. The shutter can be sticking, in which case you get lines across your image or the iris pattern. Shutters are the biggest moving part. They fail the most often. Someone left the lights on in the dome or the moon was too close. Satellite through your field of view. An airplane through the field of view. Those are cool. If you want to guess the wingspan of the airplane and do some trigonometry, you can figure out how far the plane is away. Or a bug in the system. There's literally a bug sitting on the filter wheel. So there are lots of ways the images fail. Usually it works out fine first time, but some of them they will have to resubmit. So they want to check them periodically. And the last bit's really easy. It just tells them what to observe to get ready for next week. We're going to observe the planets, and I recommend a filter and exposure time for them. That's for prompt 5. We observe the moons. So we go back to the gas giants, and we're going to observe through filters that let more light through, different observer times. It may blur out the planet, saturate the planet. It makes it easier to see the moons. Again, tremendous dynamic range. And we're going to do things with these images next week. Observe dwarf planets. So here's the list of 5 dwarf planets, what filter to use, and you can see longer exposure times for things out in the Kuiper belt. And we let them do 3 deep sky objects. Pick a nebula, pick a glob, and pick a galaxy. They can observe more if they want, but again, I'm trying to make this work for 1,000 students, so I appreciate them picking one of each. And again, it'd be a black and white picture. Then there's another section about if they want to play, some of the options they have. And I encourage them to play. They shouldn't blow through all their time. They're going to need some of it. But if they do, just give them more. And if you run out, ask, and I'll give you more to give them, because if they burn through all their time, that is your next astronomy major. And so we want to encourage them. And that's basically it for week 1 of Lab 1. Any questions so far? Okay. Again, they're going to get more sciencey. This is just learning how to use the system and having some exploratory fun. As part of the changes to the lab, we will be adding moon observation as well. It wasn't in originally because the moon's in a different part of the sky depending on where your observatory is. There's a geographic parallax effect that's now built into Skynet, so we can image the moon. So that, our moon, so that would be built in as well. That can be fun too for the students. Okay, if there are no questions, we'll pick up again here next week.
All right.
I'll send out a link to the video, and also I'll send out a link to that page with the sample labs until you get your instructor account set up. But I would go ahead and do that now. And I do encourage you to put these observations in so we can all play along together next week.
Thank you very much.
My pleasure. See you all next week.
Thank you, Dan.
Thanks.
Hey, Tad,
What's up?
send me an email.
Okay, bye.
Bye.